Greetings, Patriots. This is your study guide for our upcoming exam. Please make sure that you use this after you make the attempt and work out as many problems as you can. This should be where you check your answers. Okay, let's look at the constant rate of change and proportional situations that we've been working on, okay? So, if we just want to recap, let's go ahead and look at Sydney here. She's driving 201 miles in 3 hours and 301.5 miles in 4.5 hours. So they want to know, well, what is that constant rate of change? So multiple ways that we could find this. I know you've learned that in your classroom. So we know we're comparing our miles, right? So we have our hours and our miles. So we know that in 3 hours, she drove 201 miles, and in 4.5 hours, she drove 301.5 miles, okay? So we can actually find our constant rate of change by looking at that increase in our miles over that increase in our hours, right? Or our change in our Y over our change in X, and find our unit rate that way. Or we can simply also divide by finding our unit rate. So I'm going to choose to do that. I want to know how many miles she drove in 1 hour. So when I divide 201 by 3, that gives me 67 miles, okay? Same thing with 301.5 miles. If I take that and divide that by 4.5 miles, that will also give me 67 miles per hour. You could have found the rate of change by doing the difference here and then dividing 100.5 divided by 1.5, and you would have gotten 67 miles per hour. Let's go ahead and look at problem 2. We've been given a situation that shows us the biking and the number of miles that are biked by week. So don't forget to always label your y-axis and your x-axis. Read your labels and identify what each of those numbers mean. So we have our weeks and our miles. So by looking at this graph, I see that I definitely am going to have a constant rate of change since I have a line going in a straight line. My dots are going in a line. So I have 0 weeks, 0 miles. I have in 1 week, 10 miles. I have 2 weeks, 20 miles. So this is a nice constant rate of change where I can simply look what is occurring between 1 and 10 and 2 and 20, but I can also find the constant rate of change by doing my change in Y over change in X, change in Y over change in X, and I see that I get that constant rate of 10 over 1. So 1 times 10 equals 10. 2 times 10 equals 20. I can see that that's my constant rate of change. And what does this constant rate of change mean? Well, it means if I look at that constant rate, use your graph to help you, that I am biking 10 miles every 1 week. I need to start doing that, I'm just saying. So what's my equation? Well, in order to calculate the total number of miles, what did I consistently do? I did 10 times the number of weeks, or y equals 10x. Okay, now what we're going to do is we're going to also look at this information on problem 3 to find that constant rate of change. So once again, how do I find my constant rate of change? Change in Y over change in X. Let's go and look at our money saved, which is our Y variable, and let's look at that difference there. And let's see how it's increasing on our days. Well, on my days, I know it's increasing by 6 every single time. And in my Y, if I am not sure, can I always take 112.50 0.5 and subtract 37.50 to see what that rate of change is? Well, of course I can, and I get that rate of 75. So let me check the next one. Again, I can subtract the 187.50 minus the 112.5, and that 2 is going to give me 75. So I see that my constant rate of change is 75 over 6. Well, let's divide that and see how much money is being saved every single day. So if I take 75 and I divide that by 6, that leaves me with the following: $12.50. Okay? So my constant rate of change is 12.5. Can I always check that constant rate of change? Of course I can. So let's see if that works. If I take 3 and multiply it by 12.5, will I actually get 37.50? Well, I'm going to do that. I always want to be sure. So take your constant rate of change, multiply it out, and check if that's what you get. Well, that one works. Let me check another one. 12.5 times 9. I can do the same there as well. Okay. And that checks out as well. So my constant rate of change that's being saved is $12.50 every one day. Okay, let's go ahead and take a look at problem number 4. Maricela rode her bike at a constant rate of, they're so nice, they gave me my 0.6 kilometers per minute. So remember when we talked about this word, they gave me the unit rate. So that means I don't have to find the constant rate. It's given to me. So when I take a look at that, I know that every single minute, for 1 minute, right? So if I make my own table, for 1 minute, Maricela rode her bike 0.6 kilometers. For 2 minutes, Maricela rode her bike for 1.2 minutes, and so forth. So they're taking all the number of minutes and multiplying it by 0.6 in order to figure out the total number of kilometers that Maricela rode her bike. So I'm going to go ahead and look at my table values, and I notice that table A, they want to know which of the following tables shows this relationship, right? So 6 minutes, I get 0.6. 6 minutes, 0.6 kilometers, okay? 6 minutes, I get 3.6, and 6 minutes, I get 6.6. Well, one of these is correct, and some of them are wrong. So I'm going to go ahead and test my 6 minutes. So 0.6 times 6. I'm going to multiply this by 0.6, and this one I don't need to, but I'm going to multiply this by 0.6 and multiply this by 0.6. to see which one is correct. Since these two are the same, I will know by doing it one time. So 6 times 6 is 36, and that gives me 3.6. So this is incorrect, and this is incorrect. That was great. I hope I get some more problems like that, right? Once they give you that unit rate, go and multiply your x variable, right? In this case, the number of minutes, because that's what we were multiplying in order to get the total number of kilometers. Okay, let's go ahead and jump to problem number 5. Here, I'm being asked to look for the constant of proportionality. Okay, and we've talked about this in class, how to find my constant of proportionality. I want to check if what that is I can take every y coordinate and divide it by my x coordinate in my table and see what that constant of proportionality is. Many of you saw the connection between the constant of proportionality and the unit rate in class as well. So if this is the cost of 3 sodas, this is one of my ordered pairs. So I have 3 sodas that cost $1.08. I want to see what 1 soda costs me. So I'm going to take $1.08, divide that by 3, and when I do that, that gives me 36 cents. Well, let me go ahead and take my next ordered pair. 5 sodas cost $1.80. I want to once again see if I divide this, do I get this constant of proportionality? And I realize that this is great. I do. So 5 sodas, right? When I take $1.80 and divide it by 5, I get 36 cents. So my constant of proportionality means that I am paying that 36 cents for one soda. One soda is costing me 36 cents. So if I take 5 and multiply it by 36 cents, I should get $1.80. If I take 7 and multiply it by 36 cents, I should get $2.52. So the equation here is to get the total cost, I'm going to take my constant of proportionality, 36 cents, and multiply it by every single soda. So now I've been given the total cost, okay? So if I think about this equation, they've given me $3.96. All right, that's how much I paid for a certain amount of sodas. And that's what I'm having to figure out. So, multiple ways to do this. You can either divide the $3.96 by 36 cents, right? Or you can see that, well, my answer has to be between 7 and 13. So could I also just do this by trial and error? So could I say, well, let me go try 36 cents times 9 sodas and see if that works. That's $3.24. Well, that's short. All right, well, it can't be 9 sodas because that's $3.96. So now let me try, 11 sodas. So I can also do that. And when I do this, I realize that I have my answer, $3.96. So how many sodas can be purchased? 11 sodas. Again, you can use your equation, or you can do it by trial and error. As long as you know the constant of proportionality, you know you can figure out how many sodas gave you that cost. Okay, let's go ahead now and look at the following problem. Emily sold 15 bracelets for $67.50. Which of the following representations does not show how much Emily is selling bracelets at this rate? So we need to find our unit rate. And of course, we were taught to take that $67.50 and divide that by 15 so that we get the cost of one bracelet. I want to know that unit rate, because if I know that unit rate, then I know quite a bit of information that can help me out. So when I subtract that, I get $4.50. So, divide that, I get $4.50 for one bracelet. That means one bracelet is going to cost me, let me just set up my table, $4.50. That's my cost. 2 bracelets would be another $4.50, so I know that's $9, and so forth. 3 bracelets would be an added $4.50, and I would go on and on and on. So before I even answer these questions, I know that in order to figure out my total cost, it's going to be $4.50 times every number of bracelet. That's my equation. So there's one of these representations here that is not true. Okay, so let me go and look. Here it says Emily sells 12 bracelets and she makes $54. Well, since I know my unit rate, let me go and multiply $4.50 times 12. Well, when you take the opportunity to do that, you'll see that you get $54. So this is a yes. This shows that Emily is selling the bracelets at this particular rate of $4.50. Okay? You could have also taken the $54 and divided that by 12. Let's go ahead now and check B. So again, they've given me my bracelet sold. So here we go. So bracelet sold is 2. So that means if I take $4.50 and multiply by 2 bracelets, I should not get $4.50 because that was the cost of one bracelet. So this is definitely the wrong relationship here. It's not giving me the correct rate. And I could go on, but I already found which one does not work. If I look at C, well, I took the time and wrote my equation. So sometimes, guys, it helps to make sure you do that. If I look at my graph, I can see here's my bracelet sold. Good. and I see 4 goes with 18. Okay, 2 goes to 9. So this is showing me my constant rate of change as well for 450. So this is a yes. Letter B is incorrect, and that's what we were looking for. All right, let's go ahead and go to Miss Jordan. She wants to purchase lemons, but she's only going to buy from a store who has a proportional price, okay? So she wants her constant of proportionality, and we need to know which store gives her that. So remember, when I'm finding my constant of proportionality, I'm looking for every point, every ratio that I divide has to equal the same number, right? We've talked about that in class. So let's go ahead and look at Casey's Corner Store. If I look at Casey's Corner Store, here's my X and here's my Y. I take 40 cents for 3 lemons, and when I do that, I see that 40 cents for 3 lemons, the closest I'm going to get is about 13 cents. And, all right, let me go check 70 cents for 6 lemons and see if it's going to give me the same rate. Well, when I do that, I get 11 cents per lemon approximately, so I can know these ratios are not the same at all. So therefore, the Casey's Corner Store is not selling at a proportional rate, okay, price. So I can go to the next one and so forth. This one says I got 30 cents for 2 lemons, right? So that means that 1 lemon cost me 15 cents. I can take 60 cents and divide it by 4, and that's also going to give me 15 cents. So far, 2 times 15 cents is correct. 4 times 15 cents, this one seems like it's giving me a nice proportional price. So 90 cents divided by 6, when I do that, I also get 15 cents, and $1.20 divided by 8, well, what do you know? That gives me 15 cents as well. So did I get that 1 lemon cost me 15 cents? Looks like Mary is the market to go to for a proportional price, but we can always check Gracie. 30 cents divided by 1, well, I know that equals 30 cents. Let's see 70 cents divided by 3. When I do that, that gives me approximately 23 cents. So already, are my ratios the same? No. So Gracie is not selling at a proportional price. So my constant of proportionality here is 15 cents per lemon, okay? That's my constant of proportionality. Oh, I should have written that here. Which store is actually giving me that? Well, Mary's Mary Market. So that's the store that Miss Jordan will go to. All right, let's go to problem number 8. And if we look at problem number 8, now I'm given a graph. And in this graph, I'm having to determine which graph is showing me that unit rate that was given, where I have, right, the words per minute, per 1 minute. So that's awesome. They've given me my unit rate, right? In 1 minute, so in 1 minute, Kara can type 50 words. So in 2 minutes, that would be 100 words, and so forth. So apparently, they're multiplying, right, 50 words for every minute in order to figure out those total words, the total number of words. Okay, so let's see which graph would give me that. So again, since I know my unit rate, so now let me look at my x-axis. This one's a little hard to see. I apologize for the graphs. All right, so they're looking at 5 minutes. So 5 times 50 would give me 250 total words. So that means 10 words. Well, that one would be wrong because it would have increased. D is not an option, okay? There's not showing an increase in that graph at all. So let's go ahead and look at C. Well, I can't eliminate C yet because 5 goes with 250. So I'm going to agree that so far that's okay. Okay, and then, oh, nice, 5 goes with 125 words, and I know that that's going to be incorrect. So therefore, I'm going to eliminate that. And then I now have A, and A also goes 250 words. So what I'm going to do now is check my 10 words. So if I take 10 and multiply it by 50 words per minute, that will give me 500 total words. Well, the only correct graph will be A because C is at 10 minutes, 375. That is not correct if I'm using my unit rate of 50 words per minute. A is the best answer choice. You have to look at your graph, okay? Check each of those points, especially if they give you your words per minute. All right, let's go ahead and go to some review problems. Remember, anything we've learned in the past is always fair game. So here, Julius goes to Fiesta, Texas, pays $87.50 for 5 tickets. Well, we want to know each ticket costs the same amount. What's the cost of each ticket? Wonderful. If I know 5 tickets cost $87.50, that tells me to find one ticket. What I'm going to do then is take my $87.50 and divide it by 5. And when I do that, I get the following: $17.50. So for one ticket, it would cost me $17.50. Make sure if you're ever given a griddable item that you are entering everything in its correct place value. Okay, final problem, last but not least, is item number 10. So which of the following diagrams shows the relationship between integers and whole numbers? So remember our diagram that we've been using with natural numbers. All my natural numbers are whole numbers, and all my natural and whole are also integers, and my rational. This is the best thing to use when we're looking at our attributes and characteristics of our subsets. So I know that my whole numbers are also a part of my integer family. So because that includes all whole numbers and their opposites. So when I look at my options here, I know that A and B cannot be an option. So here it says integers are a part of whole numbers. I know that's false because whole numbers are only positive. So positive numbers and positive and whole, the best relationship here is diagram D. Okay, have a wonderful day, Patriots, and don't forget to study for your exam.